Everyone, this is Unit 3, Standard 2, Module 4, focus again on non-horizontal projectiles. So here we are going to focus on a max height problem. A physics student, frustrated with class, releases his tensions by throwing stones into the Beaver Dam. One particular stone is fired 55 degrees from horizontal, and it's fired with a speed of 30 meters per second. So the question is, how high does this stone go? So what's the maximum height it reaches? Okay, so thinking about this problem, right, we're going to have this student who's angry, throwing this stone. It goes up, reaches max height, and comes back down. Now, the interesting thing about this, right, is that if we focus this with ground to ground, the max height occurs right at the half mark. Meaning, if you can find the entire time it takes from start to finish, you take half of that time. And so the entire time from start to finish, if you take half of that time, that's going to be T max. Okay. All right. So with this problem, though, we're not going to spend the time finding T max. That's way too much. We can actually just solve for this with variables that we know right at the y max part. All right, so here's what I mean. So let's start with the very beginning. In the beginning is the student is throwing this at a 55-degree angle at 30 meters. At the very start, we have 30 meters per second fired at 55 degrees. All right, so let's find VIX and VIY. VIX would be 30 cosine of 55 degrees. VIY would be 30 sine of 55. All right, so the interesting part about this is that we're going to have to focus with y max. So what happens at the max height? So at the max height, this is what we know. We're trying to look for dy. We don't know what dy is. That's what we're trying to look. But we do know VIY, or we can solve for it using 30 sine 55. So let's do that now. So take your calculator, type in 30 sine of 55, and you're going to get 24.57 meters per second. We also know the Fy at the maximum height. So at the maximum height, the vertical velocity is actually 0. Okay, and then we don't know time, unfortunately, because we didn't solve for that total time. You can solve for that if you want to, but I'm going to show you that you don't need to. The last thing that we do know is acceleration fraction. Okay, so notice what you have here. You have initial velocity, final velocity, and acceleration. You do have three knowns. Acceleration is not 0. We could actually use one of the kinematic equations and solve for dx, right? So if you use this equation, it's vf squared is equal to vi squared plus 2ad. You can solve for displacement. So VF squared is 0 squared is equal to 24.57 squared plus 2 times negative 9.8 times distance. All right, so moving these over, so you have negative 24.57 squared is equal to negative 19.6 d. So all I did here was I subtracted by 24.57 squared. All right, so let's simplify this. So let's square the 24.57. So 24.57 squared, that's going to 603.6. That is equal to, still negative, negative 19.60. So divide by negative 19.6, divide by negative 9.6, you get 30.8 meters as the max height. Notice we didn't even need to use anything in the horizontal directions. Everything was solved for in the vertical. So, okay, go ahead and try the next two problems, and you would be done with Module 4.